Hi guys, this is Taylor and this is the History of the Atom Project Part 2. Planck was a German physicist who presented a theoretical explanation of the radiation spectrum emitted by an object that glows when it is heated. He said that the walls of a glowing solid could contain many resonators, oscillated or swung at different frequencies. These resonators collect energy in the form of heat from the object's walls and lose energy in the form of electromagnetic radiation. Planck had to assume that the energy of these oscillators could only take on a limited amount of values. Because the number of values of the energy is limited, they are in theory able to be counted. That energy is said to be quantized, so to explain how light was emitted, he proposed the idea of quantization. Einstein contributed to Planck's discoveries by suggesting that light behaved as a stream of small bundles or packets of energy. He also agreed that light was quantized. Einstein created a model that was based on two things: that light was composed of photons, which are small bundles of energy, and that the energy of a photon is proportional to its frequency. This led to the equation E equals hv, where E equals energy in joules, h equals Planck's constant, and v equals frequency in hertz. You would use this equation to find the frequency of a light with a certain amount of energy, or to find the amount of energy with the frequency of a light.
My troubles disappear when you hold me tight, and I know I'll never find another like you, so I promise that I'll never let you go. You're all I need, 'cause baby, without you, I'm just not me.
Bohr was a Danish physicist that proposed the idea that electrons were only found in specific orbits around an atom's nucleus. He improved Rutherford's model by including new information about how an atom's energy changes when light is emitted. He knew that when they are heated, elements give off color, and when they are passed through a prism, only certain lines or line spectra are able to be seen. This gave Bohr the conclusion that atoms could only emit energy in specific quantities. The emitted light was because of the electrons moving in the atom, and both Bohr and Rutherford suggested that electrons can only move in precise steps in the atom. Bohr said that these electrons occupy the energy of an atom, and once the atom gets excited, especially when it is heated, the electrons can move to higher energy levels. This amount of energy required to move an electron to another level is called a quantum of energy. Bohr also suggested that each energy level had a specific limit to the number of electrons it was able to occupy. He explained that the maximum number of electrons that the first electron shell could hold was 2 electrons, and that elements with more than 2 electrons would put the additional electrons on the extra electron shells. Heisenberg was a German physicist who calculated the behavior of electrons and the subatomic particles that make up an atom. His idea brought the mathematics portion of science more into understanding the patterns of an atom's electron. He contributed to the atomic theory by introducing quantum mechanics. He used the model of the atom to notice behaviors in electrons that make them similar and the patterns in which they orbit around the atom's nucleus. Schrödinger was an Austrian physicist who created and figured out a mathematical equation on the behavior of electrons in a hydrogen atom. He used new experimental results and theoretical calculations that went against previous ideas of the movement of electrons. His model was based off of the behavior of waves and de Broglie's equations. This resulted in an equation for the distribution of electrons in an atom. This model was called the quantum mechanical model. In this model, two things were determined: the allowed energy an electron could have and the chances of finding it in a different location around the nucleus in the atom. The model shows the probability that an electron is able to be found in a specific location in space at a specific time. His model required 3 quantum numbers or coordinates in order to show the atomic orbitals where the electrons were found. In his wave equation, these 3 coordinates were the principal, angular, magnetic quantum numbers that show the size, shape, and orientation of the atomic orbital in space. This led to another model called the electron cloud model, which showed that there was a higher probability of finding an electron in the cloud's denser areas. Thank you for watching.